This is our first debate we're having today, and the topic is when we're going about securing ICS protocols, is it a better solution to take existing ICS protocols and wrap them in TLS, or is it a better idea to have purpose-built secure ICS protocols? And David is going to take the TLS side, and Adam is going to take the purpose-built side. And their job here is to make the most compelling case for their side. So if we could turn the house lights up just for a second, I'd like to get a vote. Okay, so I can see here, I got to step forward a little bit. So going into this debate, how many of you believe that the right solution is to wrap an existing ICS protocol in TLS? Raise your hand so I can see it. Okay. And how many of you believe a purpose-built ICS secure algorithm is right? A few more, it's close, but a few more on that. And how many are undecided at this point? Okay. So we can bring the lights down. So we're actually going to do this debate style, 10 minutes, rebuttal. So if we could put 10 minutes on the clock, please. And we'll let Adam Crain go first.
All right, thank you, Dale.
And put up Adam Crain's slide, please.
Oh, that's mine.
There we go. All right, so why we shouldn't standardize on TLS for securing ICS protocols. I think that, not able to advance here. Oh, there we go. I think I'm going to lead out with what I think is one of my more compelling arguments. So the web is undergoing huge change right now. Most HTTPS traffic on the web is TLS 1.2 with a smattering of older versions, but we're starting to roll out TLS 1.3. I think it's maybe a third of 1% of all traffic on the web right now is currently TLS 1.3, but there are major changes coming. Most notably, TLS is going to basically force mandatory encryption. In previous versions of TLS, we had what effectively were null cipher suites, where we could have the data as the payload as clear text, and we could just place an authentication tag. We could verify that the message was coming from a trusted source, but we didn't encrypt the payload. So we could probably have a debate just on that topic alone, but for those of you who already have a very strong opinion on the matter, know that TLS 1.3 is going to basically force that on everyone. So what you see up on the slide there is a comprehensive list of all 5 session mode cipher feats in TLS 1.3, and basically none of them have an authentication-only mode like we used to have. Secondly, I think the second argument I think is going to be a little more subjective, but when it comes to security, less is more. And I don't think that we can ignore the substantial sort of negative impacts that unused features have on any technology and its environment. So to give you examples with respect to TLS, it's particularly bad when a mode that you'll never use is the default. So the vast majority of web traffic, and the primary purpose for which TLS was designed, was server-only authentication. So that's the default mode for TLS, and you always have to jump through a number of hoops to actually configure any TLS stack so that you actually can also verify the identity of the client, the person on the other side. Unused features are always part of your attack service, even if you don't use them. So I think one of the best examples for that in recent years was Heartbleed. So if anyone remembers what that feature was that caused the problem, it was sort of an unauthenticated application layer heartbeat message one side would send to the other. Well, the other side didn't properly validate the contents, and private keys were disclosed. So we can't ignore sort of the mountain of unused features that are part of TLS that we're probably not going to use. So there's a few examples up on that slide. Big parts of X509, which we'll talk about on the next slide. Server-only authentication, all sorts of fast resumption modes that you need to make data centers efficient, which are powering the web, but aren't really good features necessarily for sort of long-lived sessions for the kind of protocols we use in our space. So do we want to pay a penalty for this complexity for something that we're not going to use? And when you consider the patch cycle in ICS and the difficulty of patching, I think less really is more when it comes to deciding how we're going to secure these protocols. To pick on a particular protocol, X509 as a digital certificate format has been a dumpster fire of issues over the years. So we only have to go back about 13 days where we had a vulnerability in the platform security processor of certain AMD CPUs. And it was actually just a little embedded ARM core on these, so it was firmware upgradable. But the root cause was improper validation of an X509 certificate where you could get arbitrary execution basically in what is a firmware TPM. This happens all the time with X509 because of the complexity of the grammar. So, ask the Langsec folks. Dan Kaminsky did that great research back in the day with Meredith Pattison and Len Sassman, where they found all these issues where different parsers interpreted X509 certificates in different ways, and you can't really do anything except for fault the complexity of the standard itself. So my takeaway is that ASN1 is really a particularly poor choice for specifying a digital certificate format. And that doesn't even touch on the issues of, does it have the right metadata that we need for this environment? Or is it more specific to the web? Another angle that you can kind of discuss whether TLS is appropriate or not is not just the extra features that it has that you don't use, but does it have all the features that we actually need? I don't think many people have actually gone through that exercise to look at the features that we want in the space that may be absent in IT security protocols. So let me give you an example problem. In real-time control systems, timing matters a lot. So imagine that attacker can't spoof a message because of the security controls, but they can delay it. And they can delay it in a way that might affect a process. We would really want in that type of a situation are some message semantics, some security controls in our protocol that say something like, perform this action before time X or not at all. Well, that feature doesn't exist in TLS, and if the application layer protocol doesn't have something like that, you're not going to get that kind of a security control. So this is actually a protocol feature in two protocols that I'm aware of. So IEEE 1711, which is AGA 12 is sort of the ancestor of that standard. And we're doing the same thing in SSP 21, where we kind of place a time to live on the messages and establish a relative time base during the handshake within some sort of margin so that we can at least detect when an adversary is kind of delaying messages. Transport is another huge issue when you start talking about serial S. You have a lot of verticals, I think most of the major verticals, perhaps not so much in manufacturing, but electric power, water, oil and gas, all still use serial communications to a large extent. A lot of the IP infrastructure in these protocols is based on UDP. So there, you're looking at a completely different protocol for TLS. There's DTLS for that. It's not totally dissimilar, but is definitely a different code base. So the overall message with transport layer security is, I would say, it's purpose-built, but it's purpose-built for a different purpose. And that purpose really is to secure the web. And machine-to-machine communications, where you always have mutual authentication, has kind of always been an afterthought with TLS. It was a mode or a handshake mode that was kind of bolted on, but it was really developed for server-side authentication for serving web browsers and web servers. I'd like to give you one case study to kind of support this argument that we should purpose-build things. So Google has a purpose-built protocol that they call ATLS, and you don't confuse that with the web's transport layer security. They built this protocol just to secure machine-to-machine communications within their data centers. So it's basically protecting, in a mutually authenticated way, encrypted way, traffic between various processes in their data centers. Confidentiality matters a whole lot there, so it's encrypted. And I'm sure Dale can give you a copy of these slides. If you click on that ATLS link, you'll see a huge paper, and Google makes an attempt to justify why they didn't use transport layer security. And I think the two most compelling cases that they did was the size and complexity argument, which is the first quote you see there from their paper. And the second one is they didn't really like X509 and HTTPS semantics for how to specify and manage identities within their PKI. I don't think anyone in this space really has done a really good survey and requirements analysis of what would be the optimal way to do PKI within industrial control systems. And I hope that's what we can start to do with protocols like SSP21, is really explore that space and design something that isn't forced into the sort of X509 TLS box for key management. So my closing message would be that TLS is purpose-built for the web, not for ICS. I think we have more than enough funding, even especially if we design protocols that can work to wrap multiple protocols and cross different verticals. There's no reason that oil and gas and water and electric power can't come together to standardize a wrapper that provides optimal feature sets for industrial controls. And if that doesn't convince you, I'd really emphasize that mandatory encryption in TLS 1.3 is something I consider a deal breaker. And with that, I will yield.
Okay, so 10 minutes back on the clock. Let's put up, oh, wait, yeah, let's be fair to David. Give him a full 10. Put up David's slides. Okay, here you go.
It's going to be a tough act to follow. So this is why I think I have a good idea of why I think transport layer solution protocol is the way to move forward. Maybe not as an end-all, be-all for industrial controls, but for the time being and moving into the future. So there's no denying the fact that TLS is proven. It, as Adam said, is the de facto standard for the internet. And we do get authentication, and we can do authentication with machines and humans. So X509 certificates for machines, and some of the very modes that Adam complained about, we can use them for authenticating humans. So SRP is one, but we can also do things like dongles or TPMs for users, or Kerberos tickets to authenticate humans for a system as well. The very flexibility for TLS gives you, cipher suites, so you can tailor it to whichever deployment scenario you have. So the null transport mode is huge. Moving forward, though, when cipher suites are broken through advances in computing or quantum computing moving forward, hopefully, if it's done right, you can, with the right configuration, bump up to a more secure cipher suite while mitigations and patches are rolled out. TLS being established in the market is huge right now. So having multiple vendor support, OpenSSL as the standard, but there's also Wolf SSL, there's Shark SSL, there's CYA SSL, Embed, TLS, Mocana, lots and lots of options for support. Helps you roll it out into your products with quality and a quick time to market. But the other thing is industrial control processes are already moving to TLS. So Ethernet IP is based on TLS. OPC-UA has TLS-based transport modes, both for HTTPS, but also based on web services, which is TLS-like. So maybe that goes a little bit towards Adams. So. But the biggest thing right now is stepwise migration. How do you leverage your current assets and try to secure them? We're not talking about just the physical plant, not the valves, the motors, the PLCs, but what about your engineers? How do you take them from their current protocol and move them into a secure world without adding the complexity of a totally new set of application wrappers on top of that? So taking a look at how you modernize your plant, how you modernize your skills of your engineers really goes a long, long way. All right, so what's next? How do we take that, all those functionalities, and roll them into market, into products? We can take a look at what the IT world has done. We don't have to reuse SSL 3 or below. We don't have to use 1.1. We can ignore all the failure modes that were in those features, and we can start at TLS 1.2. We can use strong cipher suites, we can use authenticated encryption, and it gives us a good baseline of security. On top of that, we can leverage the worldwide support of the, I guess you want to call it the hacker community, whether it's white hat, black hat, or everywhere in between, and recognize that everybody and their brother has poked at TLS. Yes, vulnerabilities have been found, and vulnerabilities will continue to be found, but we're confident that when they are, they'll be patched quickly, and we can reassure our customers that a fix will be coming soon, and that there are expert vetted solutions and mitigations to address their current problems. After that, we have a scalable solution. When you look at Schneider Electric, or Siemens or Honeywell, they offer solutions that go from isolated single machines all the way up to cloud-connected critical infrastructure. And trying to manage identity and trust throughout that on a purpose-built application, I don't know if you really want to trust the fact that a one-off, a bespoke solution will be able to handle the mechanisms that are needed to ensure identity and trust. So self-signed certificates or manufacturing certificates for a small isolated system. You have large PKI houses for the large enterprise customers, and in between, you still have the mom and pop shops. They're the wastewater treatment plant that is air-gapped, but they still want a level of trust in their system. So, coming onto the market are on-premise CAs, dedicated boxes with hardware roots of trust, not associated with any of the big PKI houses, but available for customers to be able to leverage identities and certificates in their own system. Moving on next, we have the last bit of risk analysis and maybe stepwise migration as well, is you have your own developers. If you're a vendor, you don't need to turn your whole development team into worldwide crypto experts. You can leverage the fact that other people have done the heavy lifting, that you're paying for support, that with playbooks and best practices and guidelines, you can get a product out the door that you're confident is secure, that is reasonable and economical to test, and will provide your customers a level of security that they can implement and adapt for what they need right now. Lastly, when you look at performance, TLS it's heavy. Yes, there's a lot that goes into it for the handshake modes, the resumption times, and resumption is actually fairly important in the ICS world because you have a lot of make a connection, make a request, kill the connection. Without a session resumption, it's very difficult to maintain the periodicity and the deterministic behavior of the system without that. But you really need a hardware root of trust, especially on an embedded system, especially on a machine. So we can use that fact to put out new hardware with modern microprocessors, with TPMs and secure elements and crypto accelerators to provide the performance we need to give the security that we have. On top of that, I mean, it's really about moving a product into the field now. It's about moving the forward after, as Dale said in his keynote, a lost decade. So if we wait around for some bespoke applications to be built, it's going to be another decade. If we move forward TLS now, taking the good with the bad and putting out a quality product that our customers can use interoperably, scales well, and has good quality remedies and fixes, then I think we can really move the market forward. And that's what we're really trying to do right now.
Okay. That's great. Oh, he had plenty of time left. That wasn't fair. Okay, so now we'll do the rebuttals. So let's put 5 minutes on the clock, and you can just take down the slides and add them.
Yep.
Hit them hard.
Okay. So let me figure out briefly what order I think I want to go through for acute counterpoints there. David mentioned the learning curve, right? So you basically, if you're not using TLS, you have to have staff come up to speed on some other solution and possibly end solutions for different protocols. I personally don't feel that the end solution or wrapper or crypto controls for per protocol is really a defensible force, like the place to be. I don't think you want to die on that molehill. I think I'm more advocating for a TLS-like purpose-built wrapper for industrial control systems, and that primarily, is driven by the mandatory encryption, the complexity arguments, So I don't think it's too much to ask to have professionals in a certain space be familiar with, possibly one or two protocols that they use to wrap multiple application layers. David has a really good point when it comes to TLS traction and the availability of tools. We have a new generation of, developers entering the ICS space. Developers these days are, they're familiar with GitHub. I know Schneider probably uses a lot of open source in their projects. I really think we can do a lot better when it comes to building reference implementations and doing most of this in open source so that dev teams like David's don't have to all be experts on secure protocol design. So while I would concede that any new protocol is not going to have that infrastructure and environment, if we share and do this together, if there was a consortium was built around a wrapper purpose-built for ICS, I think that's well within the realm of possibility that we could do, and we could do well within this space. David mentioned TPMs and hardware roots of trust. I don't think that excludes purpose-built protocols. I mean, TPMs do a lot of things. They can do things with X509, and that's something TPMs wouldn't have with a purpose-built certificate format. But they also do a lot of low-level crypto acceleration. But the most important things is they keep your private keys private, right? And I leverage that capability with any other protocol that needs to store private keys. I don't think that purpose-built protocols can still certainly leverage the capabilities of a TPM, that you just might not use it for the digital certificate processing. But if you have a really simple purpose-built digital certificate format, something that can be parsed without mallocing all over the place and has a decidable grammar, you don't need the TPM so much because you at least trust your application layer code to parse and handle that certificate, and you can just leave the crypto and the key management stuff to the TPM. What else? Those are my major rebuttal points. I'll leave it at that.
Okay. So let's put 5 minutes back on the clock, and David, what has he got wrong?
Going back to Adam's presentation with the purpose-built application, he mentioned TLS 1.3 and the mandatory encryption being a deal breaker. A lot of people look at that and they say, we need IDSs. Sorry, I'm blanking. Anyways, we need systems to be able to monitor the traffic, to do anomaly detection. It can be done in encryption now. Cisco just released a paper the other day that says they can detect anomalies in data flows, even in encrypted packets. But the bigger message I have to say for a purpose-built application is the interoperability issue. We saw a lot of presentations earlier today about cloud. The gentleman from the CSA, the Cloud Security Alliance, had a slide about fog, and that's coming. It really is coming. And to be able to build a system that interoperates with cloud technologies from Azure and PLCs all the way down to sensors, I don't think you're going to be able to get through a firewall. If you call up your IT guy and say, hey, I need this random weird-looking packet to go through the firewall, they're going to tell you to go pound sand. So TLS, it'll buy you a lot through there because they know what they're looking for. They can look for rogue certificates. They can look for weird traffic patterns. And they'll be at least OK with you maybe passing some data through the field. X509 certificates, yeah, they're a mess. There's no getting around it, but they are the de facto standard. So unless somebody else can come up with an easily extensible form for an identification that has all the fields needed to support web traffic, but also other ones for industrial controls, good luck trying to get all the PKI houses to adopt that, because they're not gonna. So we really need to work with those guys to make our lives for rolling out IoT devices and industrial control devices better. So swimming upstream with the PKI houses is probably not gonna buy you a lot of leverage too. A lot of this goes back to getting product in the hands of our customers, of making their assets a bit more secure. So the technical points between TLS and a more bespoke application wrapper, probably about even. You can find issues either way. It's time to market. It's securing your products and your customers' products. It's staving off the next, or preparing for, I guess, the next generation of industrial controls. It's about really just paving the way of trying to not do nothing like we've done for the past 10 years.
Okay, great.
There was still 2 minutes.
So why don't you put 10 minutes on the clock so I keep us on schedule for the welcome party tonight. And now I guess I'll just ask you guys some questions, but also feel free to have a conversation between the two of you and ask each other questions. I guess, David, maybe I'll start with you. The encryption issue in 1.3 is, I was actually going to say you didn't address that, but you just did very well, your thoughts on that. But isn't that almost a symptom of a problem in that TLS is built for a certain set of applications of which we're kind of an odd case for, and 1.3 has this, but we're not going to have much impact on what is in 1.4, 1.5, 2.0. Are we potentially putting ourselves in a dead end there if they do something that we really can't live with?
I don't think so. I think the encryption piece, you need to take a look at what it's for. It's really about securing it while it's on the wire. If you have complete repudiation on your system with logs, then you don't need to have something sitting on the network to monitor what's going on. Your end devices should be able to log that activity as well. And as far as voices for 1.4 and 1.5, et cetera, I don't see why we can't have a seat at the table for the IETF. They're usually more than welcoming to have more voices in the room.
Yeah, I think that was the case, though, that if we had a seat at the table and we had people from this community participating in the IETF, particularly on 1.3, we wouldn't be in a situation where we didn't have options in terms of encryption versus authentication only. I think there's quite a bit of effort going on with the IEC, the various standards telling people how they're going to do packet inspection or so forth. And I know people in those committees, and it was a huge surprise to them when I told them over the last few months, oh, by the way, not only does TLS 1.3 force encryption on you, but it also says you have to use perfect forward secrecy and ephemeral keys. So the only way to get at that traffic is either have the other ends decrypt and send logs, or be an active man in the middle with the private keys. I mean, it hides everything. I mean, it even hides the certificate data.
Well, then to you, Adam, I guess that one of the things that's just been, it actually started last year with something Brian Owen said in a panel up here, but my discussion with Dan Gear, Ralph's presentation, a variety of others, I was just pounded with speed and time. Everything seems to be moving faster. We have limited resources. We have to make choices where we're going to put our effort, where we have a chance to be successful. And even under you've been involved in algorithm preparation, even under a good circumstance, you're talking years before you get to something where people agree, and then they start to do pilots, and then it's a rollout. How do we have time to wait for that?
I mean, I think it could be incremental. I mean, I see no problem with the current efforts to wrap things in TLS. Those capabilities could certainly exist next to each other for a period of time. I mean, SSP 21 is now a year and a half old, and we're approaching the date at which we can release this open source and actually start standardizing. So, we have something that we think is solid. We have the capabilities in it that we think people in this room need. So we're looking at maybe 1 to 2 years to go through the standardization process, but I don't think it's 5 years off.
So if we're talking about purpose-built ICS algorithm, are we by nature talking about purpose-built wrapper?
No, we're not. I mean, in fact, there's a lot of efforts within these industries. You have groups like the DNP3 user group adding actually adding extensions into the protocol itself. I'm not a believer in that approach simply because of market share and feasibility. And do you want people to, have to learn n different security ways of securing a protocol for the n different protocols they use? I'm much more a believer in a wrapper and a technology that can be used across a number of protocols and hopefully even a number of verticals. That's where I think we get the scale is collaboration across protocols and verticals.
And feel free if you have a question for David, we can jump those in and vice versa. But David, when you were involved with Secure Modbus, did they look at taking more of a DNP3 approach or building something on, or was it a pretty quick decision to wrap it in TLS?
Quite honestly, Modbus is so simple. I don't think we needed all the complexity that DNP3 has because it's master and slave. I mean, DNP3 is master and slave too, but it's dead simple master and slave. There's no object-oriented things like DNP3 has.
So we need Jack up here to ask him that question about the CIP standards, if that was a tough decision. But
yeah, I was not involved. I was late to the party for the ODVA specification writing, so it'd be interesting to see what they had to say.
Do you agree though that it is with Adam that it would be, even if you were doing purpose-built, you'd want a wrapper solution?
For us, I mean, Modbus, we took the approach we did with Modbus because we recognized the fact that it has market share because it is so dead simple. And by choosing TLS, it was, I know the marketing people say low barrier to entry is a bad thing, but technically speaking, it's a low barrier to implementation. So in a few weeks, you can implement Modbus Secure. We've done this. I'll talk about it on Thursday. We had an interop back in May, and we had about 2 man-weeks of effort into it, us and 3 other companies. And we got together, totally sight unseen, just looking at the specification, and we could talk. Everything was encrypted. We had some secure certificate issues to iron out, but we were getting there. If you take a look at OPC UA and you look at their secure conversation stuff, and you try and implement that from scratch, you'll be there for months. Good luck.
So Adam, when you were looking at these protocols, why did you not take the approach of taking one of these protocols, whether it be something simple like Modbus or something more complex like Ethernet IP, and creating a wrapper around that?
Well, that's what SSP21.
So when you're doing SSP21, you're wrapping it around what?
You're wrapping it around the application layer. You don't have to, I mean, some of these protocol stacks have multiple layers, like Ethernet IP. You're kind of like dividing things into 2 pieces, right? DNP3 is internally divided into 3 pieces. So, for instance, with SSP21, we have a frame type you can use, and then there's this message-oriented crypto layer. And you don't have to use both parts. You could insert that message-oriented cryptographic layer somewhere in the middle of the stack. The nice thing about that is it would, enable incremental migration if you have like a multi-drop network. Say you're a water utility that has a 900 megahertz point-to-point radio. If you modified the protocol stack in that manner, you could incrementally upgrade nodes. You wouldn't have to make them all secure whatever nodes at the same time, because the messages that aren't kind of addressed to you, you just drop on the floor and ignore. That's going to be the sticking point, I think, for a lot of systems.
So maybe just as the last thing, and you guys can answer this, whoever has an answer first can go first. What would be your biggest concern if the other side of the argument is what the ICS community adopts? So, Adam, what would be your biggest concern for the community if they do wrap it in TLS? And David, what would be your biggest concern if we go down the specific purpose-built algorithm route?
Probably being forced to do HTTPS-style key management.
Key management?
Yeah.
Okay. And David?
Mine would be the balkanization of security schemas in industrial controls. Everybody's moving to IP already. We have 802.3 CG, which is 2-wire Ethernet. So we can take all the old serial networks. We can turn them into multi-drop Ethernet networks. We can leverage that.